It's claimed that the Nimitz FLIR video from 2004 shows an unusual flying craft performing a series of high-G maneuvers, culminating with it shooting off at an inhuman rate at the end of the video. But I think it actually shows an ordinary-seeming craft moving with constant velocity, making no sudden moves. To help demonstrate this, I made a version of the video overlaid with a timecode and larger versions of relevant information from the display. I corrected the zoom indicator changes between 1x and 2x, so they happen on the actual frame of the zoom change and not a few frames later as they do in the original. I added indicators when there's some kind of lens change or a gimbal adjustment or other events that cause apparent motion. There's a link to this version of the video in the description below. The number at the top shows the heading of the camera in degrees relative to the front of the plane. This goes from 4 degrees right to 8 degrees left. The horizon indicator in the middle shows that the plane is not turning, so this means that the object has an apparent angular movement to the left. The indicator gets a bit squirrely around 0, probably due to gimbal lock issues, but if we take the 7 degrees of motion from the start of 1 degree left at 44:15 to the start of 8 degrees left at 1:12:27, that's 7 degrees in 29 seconds and 12 frames, or about 4.2 seconds per degree of leftward motion. So we've got this object moving left. The camera is tracking it so it stays in the middle of the screen. You can't see any background in the video, so there's no visual frame of reference for the motion, but it might look something like this if there were some clouds just behind it. To accurately get the speed here, I set the field of view in the 2x narrow mode to 0.35 degrees, as found in the SCU report. So it takes about 4.2 times 0.35, or about 1.5 seconds to traverse a frame. What would happen if the camera stops tracking the object? The object would then just keep moving left at the same angular rate, taking about 3/4 of a second to leave the narrow 2x view, and that's exactly what we see. So why would it stop tracking? Well, the camera is tracking the object visually. We know this because every time there's a physical lens change or a camera change or a sudden rotation of the camera, we can see the lock being briefly lost. You see the bars expand as it tries to reacquire the target, then they contract around it when it's locked on. But while it's locking back on, or if it never locks back on, then the object will just continue its motion to the left, looking like it's suddenly changed speed when it's actually just the camera. So here's what happens in this video. At 0:40:29, there's a lens change from TV mode to IR mode. Lock is very briefly lost. The object goes to the left for a few fractions of a second, and then the camera catches up and the tracking continues. At 0:43:13, there's an interruption of the video. Lock is again briefly lost, a slight leftwards movement, and then we are locked back on again. At 0:49:06, the camera does a gimbal rotation adjustment to prepare for transiting 0 degrees. You can see that the entire scene rotates. Lock is lost, and the object ends up a bit to the left. It drifts a bit more left, and then we lock back on. At 0:55:20, there's a similar thing with a very tight circular movement and a small movement to the left. At 1:11:28, there's a lens change from narrow to medium fields of view. Because this is the same camera, there's less blanking. So as we transfer between lenses, we see the object seem to shoot off to the bottom left. It then reappears in the center, but as we've lost tracking, it moves slightly to the left. The reticle expands, we lock back on and back to tracking. At 1:14:00, a similar thing happens going back to narrow, but with the change being more obscured. The object vanishes and reappears slightly to left to center. It's just outside the target reticle and we've lost lock. The reticle expands, but the object has already started to move left. The reticle expands again, but now the object is outside and moving left. So it never gets the lock back and the object drifts leftward. We're in at 1x zoom here, so it's not moving left that fast. But then, at 1:14:14, the pilot switches from 1x to 2x zoom, causing a sudden jump in the apparent position of the object. It then continues to drift off to the left twice as fast as before, at exactly the speed we calculated earlier. So all the apparent movements we see are consistent with the object simply moving in a straight line to the left. So this is perfectly consistent with something like a distant aircraft, just flying along quite normally, making no sudden movements. So if this interpretation is correct, what does it mean? It means that To the Stars Academy is wrong. It means the experts on the History Channel were wrong. It means the SCU report is wrong. It means Jeremy Corbell was wrong. And it even means that about this one thing, Commander David Fravor was wrong.
And then when they get close, it's going to zing off the left-hand side. And off it goes to the left. And that's pretty fast to leave that field of view.
When it just sort of like leaves the field of view and takes off to the left, how fast is that going?
for something to leave the field of view that fast with the pod just staring is pretty fast. I mean, it's like out of here.
Of course, that does not mean he was wrong about anything else. Nor does this video showing something moving in a boring way mean that it's not a UFO, nor does it mean that Fravor and other people didn't observe different things doing more exciting things at different times. It just means that, despite what everyone was saying, the Nimitz FLIR object is not an extraordinary craft. It makes no sudden moves.